TQM and planning tools. The objectives of this topic are: identify quality tools for planning, illustrate application of each quality planning tools, apply planning tools in quality problems. There are several basic tools of quality can be used singularly or in tandem to investigate a process and identify areas for improvement, although they do not all necessarily need to be used. So here are the different quality tools for planning. Number 1, cause and effect or fishbone diagram. Number 2, Pareto chart or diagram. Number 3, check sheets. Number 4, histogram. Number 5, control charts. Number 6, scatter diagram. Number 7, flow chart. So, what is cause and effect fishbone diagram? It was first used by Ishikawa in the 1940s. Also known as a fishbone diagram, it is employed to identify the underlying symptoms of a problem or effect as a means of finding the root cause. The structured nature of the method forces the user to consider all the likely causes of a problem, not just the obvious one. It is called cause and effect diagrams after its functions and fishbone diagram take after its appearance. Its function is to identify the factors that are causing an undesired effect or defects for improvement action or to identify the factors needed to bring about a desired result or a winning proposal. As a starting point, major factors could be designated using the 4 M's: the method, manpower, material, and machinery, or the 4 P's: policies, procedures, people, and plant. Factors can be subdivided, if useful, and the identification of significant factor is often an introduction to the statistical design of experiments. In order to use the cause and effect diagram as a tool, there is a need to first identify the problem. One is trying to solve and simply write it in the box head of the fish to the right. Next, he will list the major causes of the problem on the spine of the fish. Causes are then identified during brainstorming with a group familiar with the problem. Once all the possible causes are identified, they can be used to develop an improvement plan to help resolve the identified problem. Here is an example of fishbone diagram, the Ishikawa diagram. The main problem is shown on the right: iron nails out of shape, rusting. This means that the problem that is dealt with the incorrect dimension of the nails due to rust. The nails are rusty and out of dimension. Then the main categories are identified and potential causes from each of the categories are identified. Pareto chart or diagram. Alfredo Pareto was an economist who noted that a few people controlled most of a nation's wealth. Pareto's law has also been applied to many areas, including defects, which are few causes are responsible for most of the problems. The Pareto principle is based upon the principle which states that 80% of a problem is attributable to 20% of its causes or inputs. A Pareto chart organizes and displays information in order to demonstrate the relative importance of various problems or causes of problems. It is a vertical bar chart with items organized in order for the highest to lowest relative to unmeasurable effects such as frequency, cost, and time. Pareto chart can help prioritize quality problems and separate the vital few problems from the trivial many by plotting the frequencies and corresponding percentages of a categorical variable, which shows how to focus efforts and resources. Here is an example of a Pareto chart. Check sheets. Check sheets are also known as data collection sheets and tally charts. Check sheets are non-statistical and comparatively easy. They are used to capture data in a manual, reliable, formalized way so that decisions can be made based on fact. As the data is collected, it becomes a graphical representation itself. Areas for improvement can then be identified. either directly from the check sheet or by feeding the data into one of their other basic tools. A check sheet is an organized way of collecting and structuring data. Its purpose is to collect facts in the most efficient way. It also ensures that the information that is collected is what we ask for and that everyone is doing it in the same way. Data is collected and ordered by adding tally or check marks against predetermined categories of items or measurements. It simplifies the task of analysis. Here is an example of a check sheet. Histogram. Histogram is a form of bar chart used to measure the frequency distribution of a data that is normally grouped together in ranges of pins. It also used to tell the different regularity of occurrences in long list of data. For example, 2233334456. Number 3 occurs the most frequently. However, if the list comprises several hundred data points or more, it would be difficult to ascertain the frequency. Histogram provides effective visual means of doing so. It shows patterns that fall within typical conditions, and changes in a process should trigger new collection of data. Also, a minimum of 50 to 75 data points should be collected to guarantee a sufficient number of data points have been gathered. The patterns that are detected reveal an analysis that helps understand variation. Here is an example of histogram from Quality America Incorporated. Dating back to the work of Sherwood and Deming, there are several types of control chart. They are practically complex statistical tools that measure how a process changes over time. Through plotting this data against predefined upper and lower control limits, it can be determined whether the process is steady and under control, or if it is erratic and therefore out of control. Simply, these charts demonstrate when the data is consistent or when there are high or low outliers in the occurrences of data. Control chart focuses on monitoring performance over time by looking at variation in data points and distinguishes between common cause and special cause variations. The Dow Jones Industrial Average is a good example of a control chart. Control limits are values that sample measurements are not expected to exceed unless some special cause changes the process. A sample measurement outside the control limits therefore indicates that the process is no longer stable and is usually reason for corrective action. This is an example of control chart. The Dow Jones Industrial Average. Dow Jones Industrial Average is a good example of control chart, used to monitor processes that are in control using means and ranges. It represents data like sales, volumes, customer complaints in chronological order. Upper and lower warning are action lines. Scatter diagrams. A scatter diagram is used to identify whether there is a relationship between two variables. It does not prove that one variable directly affects the other, but is highly effective in confirming that a relationship exists between the two. Variables often represent possible cause and effect. It is a tool for analyzing relationships between two variables for determining how closely two variables are related. One variable is plotted on horizontal axis and the other is plotted on vertical axis. Here is an example of scatter diagram. A scatter diagram might show the relationship between how satisfied volunteers are that attend the orientation training. The diagram shows the relationship between volunteer satisfaction scores and volunteer orientation training. Flow chart. It is a visual representation of a process. It is not statistical, but is used to piece together the actual process as it carried out, which quite often varies from how the process owner imagined it is. This tool is used when to determine where the bottleneck or breakdowns are in work progress. It is sometimes called a process map. It can be used to help the company model its process and understand and communicate all activities in the process, the relationship between inputs and outputs in the process, and key decision point. Here is an example of a flow chart. These are the flowchart symbols. A danger in flowcharting is the use of assumed or desired steps rather than actual process steps in making the chart. The utility of the chart will correlate directly to its accuracy. Another danger is that the steps plotted may not be under the control of the user. If the analyst does not own the process, the chart may not be too helpful. It may, however, be quite useful to process improvement team, including all the functions involved. That's all. Thank you for listening.